So we're going to finish up the chapter here by looking at some complete hypothesis test examples. First up, we've got a new cholesterol drug that's being investigated in a clinical trial. A researcher hopes to establish that the drug lowers LDL below 100. So that's referring to HA, what we want to show. There are 80 subjects in the experimental group, so that's the sample size, n equals 80. And their mean, we're dealing with means, LDL after 6 weeks of treatment is 96.2. So that's saying X bar is 96.2. And a standard deviation of 15.4. So that's saying S is 15.4. Perform a hypothesis test at alpha 0.05 to determine if the drug is effective, which means it lowers LDL below 100. So we're dealing with means, so our H0, HA are going to be mean. We want the mean to be less than 100, so that's our HA. And then our H0 would be mean greater than equal 100. Determine our distribution. We're dealing with means. We have S instead of sigma, so this is going to be T distribution. And then also our assumptions here. First, we need a random sample. And we can assume that the sample is random because these are subjects in an experimental group. So it's a clinical trial. They always randomize in a clinical trial. Secondly, our sample size n is 80, which is greater than equal 30. And we either need n is greater than equal 30 or approximately normal population. We've got the n greater than 30. So now we can compute our test statistics. So our X bar there is the 96.2. We are subtracting off the hypothesized value, that's our 100, and then divide by S is 15.4 over the square root of n here, which is 80. Let's go ahead and enter that in the calculator. So alpha y equal enter for a horizontal fraction, 96.2 minus 100 up top. And the denominator, 15.4 divided by square root 80. So about negative 2.21. Next, we want to sketch and determine our p-value. So negative 2.21, this is our t distribution, 0 in the middle here. So negative 2.2 would be about right here. And then the p-value is the area to the left. So that little sliver, that's our p-value. And so our p-value we can compute with TCDF. The left cutoff is negative infinity, the right negative 2.21. So we'll do negative 10,000 to negative 2.21. And then you also enter your degrees of freedom, which are 1 less than sample size. So 79. Plug that into the calculator. So second variables, get to our distribution menu. TCDF is number 6 on negative 10,000, negative 2.21, degrees of freedom 79. So I'd already entered those in. So 0.01499, so 0150, so 0.0150 to 4 decimal places. Make our decision. So our p-value here is 0.015, and that is less than our alpha right there, 0.05. So that's going to tell us reject H0. And then go ahead and interpret that conclusion. So what does it mean to reject H0? That means that there is sufficient evidence to conclude that HA is true, and that was mean less than 100. So to conclude mean less than 100. So in other words, the drug works. It's doing what it's supposed to do. We can also check this on the calculator using the t-test function inside of stats. So we can go to stat, arrow to tests, and then t-test is number 2. Make sure it says stats. And then our mu0 rate here is 100. X bar I put in 96.2, standard deviation 15.4, sample size is 80, and then I came over and checked the less than. And if we go ahead and you can either calculate or draw. So if we calculate, there's our t and our p 0.0151. We were off by just a little bit. Or if you do the draw, then it actually draws the distribution and shades in the p-value for you and gives you t and p. So you can confirm this always on the calculator. So again, these small p-values are good. They mean that the result is statistically significant.